In this video clip, I am trying to explain how to do problem 1 of problem set 1. So here we have matrix A, which is 4 by 4, matrix B, vector B, and in part A, we are trying to find all permutation matrices P1, P2, P3, coefficient matrices M1 to M3, and lower triangular matrices L1 to L3. And then from these, we're going to calculate PL and overall U. So to do that, I'm going to show you two different ways which actually give the same result. So let's look at how we can do it. In method 1, so we do not permute rows in ascending order. We just bring the maximum element to the diagonal. Okay, so let's see. In matrix A, 10, which is the maximum element in column 1, is sitting in row 1, so we don't do any permutation, and that is leading to permutation matrix 1 equal to identity matrix like so. Now, we can do that and then multiply A by permutation matrix to see what gives us. Okay, let me run it up to that point. Alright, so here is the matrix, which actually doesn't change because we multiply by permutation matrix, which is identity matrix. Now, in the next step, we have to make zeros on the first column from row 3 to row 4. And because we want to make these zeros, the coefficient matrix would look something like the following, right? So we have to multiply this by 310, well, multiply the first row by 310, multiply the first row by 5 over 10, and multiply the first row by 1 over 10, and add to row 3, 2, 3, 4. Okay, so that would be your coefficient matrix. Now, if you do that, what you get is the following. So now, when you multiply M1 by P1 by A, you should get zeros, as you can see here on the first column. Okay, so now in the next step is we look at the second column and bring the maximum element to the diagonal. The maximum element is 5 over 2. We switch row 2 and row 3 such that 5 over 2 actually comes to the diagonal element. And to do that, we have to have this permutation matrix, which switches row 3 and row 2. Okay, now when we do that, we're going to do this. Now we multiply the resultant matrix by P2 so far, and we have to see that the maximum element actually now is in the diagonal, right? Now we have to make zeros below the diagonal, and that is by multiplying the second row by 1 over 10 and then minus 17 over 10, okay? And no, excuse me, you have to multiply the second row by 1 over 25 and 17 over 25. Okay, so and these are exactly over here. Now this would be our coefficient matrix. So let me do that. Okay, now the resultant matrix so far would be M2 P2 times whatever we got so far, which is A2. So remember, A2 was M1 P1 A1. Okay, now let's do that, and you see that we get zeros below the diagonal. Yes. Now we move on to the third column. We look for the maximum element, and fortunately the maximum element is sitting on the diagonal. So the next permutation matrix would be identity matrix. Okay, as you can see here. Now let me go one more step further. Okay, now when you multiply this identity matrix by the current coefficient current A matrix, basically nothing changes because permutation matrix is equal to identity. Now, you have to make 0 below the column, below the diagonal in the third column, we can see that the coefficient should be 12 over 31. So this would be our final coefficient matrix. Okay, now we multiply the matrix A by that, and we get zeros below the diagonal. Okay, now we got M1, M2, M3, we got P1, P2, P3. Now how to calculate L matrices? Well, here is the relation. Okay, maybe we didn't discuss this in class, but this is very short way of getting L matrices. Okay, so L3 is equal to inverse of M3. L2 would be P3 inverse of M2 P3 transpose. L1 would be P3 P2 inverse of M1 P2 transpose P3 P3 transpose. Now we can actually look at this, and then we can deduce how, you know, L matrices can be derived if dimension of matrix is bigger than 4. So you can actually see the pattern how it goes up. Now once you get L matrices, then you multiply L's and you get the overall L. This would be our upper triangular matrix, which is M3, P3, A3. And then the overall permutation matrix would be P3, P2, P1. Okay, so if you do that, we can then compare with LU factorization from MATLAB. So let me continue all over to the end, and then just pull this up so you can see and compare the result. So this is our permutation matrix, which is by multiplication of P1, P2, P3, and the bottom here is what MATLAB gives us. And if you compare these two, this and that, you see that they're exactly the same. Now, you can also compare upper triangular matrices. This is what MATLAB calculated, and this is what we got. And if you compare, they are exactly the same. And these are stars. Actually, these are pretty much zeros because of round of error. MATLAB cannot represent it as exactly 0. Now, let's move up and then look at the lower triangular matrices. So this is what MATLAB gives us, and this is what we calculated. And if you compare them, you see that they are exactly the same. All right? So this was method 1. Method 1 was we just moved the maximum element to the diagonal. Now, in method 2, which is different from method 1, we actually order the columns in descending order. Okay, so we bring the maximum to the diagonal, but then we order the whole column. That means here the first column would be 10, 5, minus 3, 1, because we have to order them, right? And to do that, the permutation matrix would be something like this. All right, so let me run that. Okay, now we can see that the first column is ordered now. Well, in terms of the absolute value, if you forget the signs. Now we can keep doing this every time we multiply by the coefficient matrix. We permute the rows such that we make the column in descending order. Okay, so here would be our M1. We multiply the matrix by M1 P1, and we get this. Now we have to order this again. That means we have to switch row 4 and row 3. And to do that, the permutation matrix would be this, because we want to switch row 4 and row 3. All right, so let me do that. All right, so here we go. Now the second column is also in descending order. Now we can multiply by the coefficients. Okay, so the coefficient matrix would be something like this. The third element would be 17 over 25, and the fourth element would be 1 over 25. Okay, so let me do that. Again, now when we look at the third column, it's not in descending order. We have to switch row 4 and row 3. And to do that, the permutation matrix would something like this. Okay, so let me do that again. So here would be in descending order in the third column below the diagonal, and then the final step would be the coefficient matrix, which is 12 by 31, okay, and that is right here. Okay, so let me do that. Okay, so we got M1, M2, M3, we got P1, P2, P3, and then we use the same relationships to find L matrices. Okay, and if I continue all the way to the end, we can now compare MATLAB results with our result. And again, you see that this is MATLAB result for P matrix, and this is our result for P matrix, and they're exactly the same. You can also compare upper triangular matrices. This is MATLAB result, and this is our result by multiplication of L's and U's. Sorry, L's and P's. Okay, now we can also compare L matrices. Here's the MATLAB result, and here's our result. You see, exactly the same. So regardless of which method we're going to use, down the road we get same L, U, and P. Okay, so this actually solves part 1, 2, and part 1, 2, and 3 of problem 1. So hopefully this can help you solve problem 1.